Andres, as much as I like this intro music, I think I'm just going to start us 40 seconds ahead of time.
Sounds like a good idea.
There we go. I did it. Okay. Well,
hello, Alan.
Welcome. Good morning to you. It's afternoon for me.
Yeah, it's
morning
11:02
for you. This is one
me.
of those weird bridge times that where one of us is in the morning and one of us is in the afternoon. And what's even weirder is that I think you're like further east than I am right now.
Yeah. So I'm in Monterrey. I'm in Mexico, but the northeast of Mexico, but Mexico doesn't have daylight savings. So this usually is Central Time, but it's currently Mountain Time. So it's the same time as in El Paso. So it's weird.
That is super weird. And happy birthday to your wife. My phone told me today that it was your wife's birthday. It's not weird.
It is. She's having breakfast right now. Yes, it's late. Oh, let's call it
her
brunch.
birthday. She's allowed to do.
Yeah,
she's allowed to do what she wants for her birthday.
Yeah. So
good. Excellent.
It's gonna be a good day.
Well, you know what we're going to try today?
Yeah,
we're going to try. We're actually going to try several things today. One, so for anybody that doesn't know, we stream this show through an app called StreamYard. It allows us to stream at the same time to LinkedIn and Twitter/X and YouTube and Twitch all at the same time. We kind of get this centralized dashboard. And so they're a SaaS, which is my favorite thing because we just keep using it and it continues to get better. So they just released something in beta that says show comments on stage. I'm going to turn that on right now and we're going to see what happens. So it's currently on. So if somebody wants to comment somewhere, either on YouTube or on LinkedIn, send us something right now so we can see if it just automatically pops up on screen, because I'm curious. We've already had a few on YouTube so far. So if somebody just wants to say hi, let's see if we can see you. That'd be pretty neat.
Hey, there's Daryl.
Daryl, he said Texas.
Yeah, we love Texas.
That works for me. Works for me. Okay.
Nice.
All right.
Okay. We'll cover my face if we get a lot of comments.
Probably, but that works out.
It's fine. I'll do like two-face. What is it?
We're going to be showing the screen and we will it's not going to cover your face.
I like that.
So hello everybody. Thank you for your engagement.
Hello LinkedIn user Peter.
All right. Yeah, there's not great support on StreamYard for LinkedIn. Like, I don't know who that was on LinkedIn. We might have to just watch that on our own. But thank you. Thank you for showing up.
We appreciate everybody.
Yeah, thanks for calling it out, Daryl. We already prepared to turn this off if the spam starts. So thanks for making people aware that they can.
I like that it fades away before it gets to my face, so that's good.
Yeah, that's intentional, I guess. I could probably drag it around the screen. It doesn't matter. That's actually not what we're here for. As cool as this is, we might do like a short episode one time on this because I actually really like StreamYard. We're here today to talk about A2A. And I made the clickbaity title, Is it the new MCP? And I'm just going to answer right now. No, because they don't solve the same problem. So no, they're not. But we're here to talk about it at length and in depth because I've done a lot of research on A2A. I was just at a conference last week it was actually the Postman conference, but it was very AI heavy and everybody was talking about A2A and just kind of wanting to understand what is it, what problems does it solve, how is it different from MCP, so on and so forth. So we're going to talk about it and we're actually going to show an implementation of it, which is the big thing that I feel we has been missing. And I love that comment.
Yep.
Love Alan to Andres. That's perfect.
It works out. That would have been perfect. Okay.
Yeah, you're right. You're right. That's shame on us for not thinking about that. Okay. So A2A, Andres, You know what I love about this show?
Tell me.
We come into this and I have all the answers and you know none of them. And I love putting you on the spot because you have such good, like, it's a joke and it's not a joke. You have really good reasoning and your intuition on things in tech is actually very good. So when I put you on the spot, you're not usually that wrong.
Sometimes.
A backhanded compliment to you. So let me ask you, what do you understand A2A to be?
So, I mean, I did actually read a little bit, so I'm not completely foreign to A2A, but so going back to what we've talked to about, like in the few previous episodes, MCP is a way to formalize communication between an agent and tools, right? With A2A, agent to agent, it's formalizing the communication protocol between agents. So giving you a structured format for messaging or the back and forth communication that they can have and all that stuff. It's kind of providing a standard way for these to communicate. So I can have an agent here, an agent over there, and they can communicate, discover their capabilities, and make sure you can create that nice multi-agent collaboration. How wrong was that?
I mean, you weren't that wrong. You were, I mean, most of what you said was right. And in fact, all of what you said was right. It's just not the full picture.
Yep.
So
that's what we're here for.
That's right. That is what we're here for. So, like, a big distinction that I don't think people understand with A2A until they actually start implementing it or reading the code. It's solving a significantly larger problem than MCP is. Like, significantly larger. MCP is a protocol from Anthropic that standardizes how agents communicate with tools and discover resources and prompts. It does a couple of other things as well, but it's it's the guidelines of how to formalize that communication. A2A does that with agents, but agents aren't essentially one-shotting. In
Yeah.
To put it lightly, one shot meaning you ask it something one time, it does one thing, and you're done. Typically, what we're going to see A2A, where it really shines the most, is in complex or multi-step workflows that have a bunch of different steps. If you think about the live stream, Andres, that you and I did like 2-3 months ago, where we recreated the virtual office, where we had a bunch of different agents, where we had, Pam, the graphic designer, Angela, the head of the party planning committee, a bunch of different ones, right? And then we had Michael Scott as the boss, and he says, "Hey, I want a pirate themed party with a real rum barrel." There's a bunch of things that go into that because there's communications, there's generating the graphics, there's figuring out what the budget is, there's renting the supplies. It's a whole bunch of different things that all generally get tracked back into ultimately one task. And so what A2A is doing is it's figuring out, how do we track the tasks? How do we track the messages? What are the different artifacts that are going back and forth? Because everything needs to be self-contained, because in all likelihood, these agents aren't running on the same box. So they're going to have to communicate with each other in a very standardized way.
Yep.
And in addition to the standardized way, it also has to be flexible, because nobody likes being pigeonholed, especially developers. So it has options for things like request response and for streaming responses. And this is really based on what you and or your calling agent is needing, right? What your requirements are. So there's a lot to it. And there's a lot of components.
It's meant to be already in kind of that multimodal, I can't pronounce that word, multimodal fashion, right? Where it can ask for via prompt, just ask for a video or a audio or stuff like that. And so it's kind of standardizing that communication as well. So not just the one-to-one that we're used to.
Right. Yes. So let's talk about practicals, because that's what we're all here for, right? We're here to see the cool stuff, the real implementations. I was going to draw a bunch of diagrams to show you, how does A2A fit in, how does MCP fit in, what are all the components to this big ultimate AI architecture in the sky. And then I went to Google's website for A2A. A2A is from Google, and they have all the documentation there with graphics and stuff. So we're just going to look at that to save myself a lot of work because it was totally unnecessary to redraw what Google did. I will talk about it probably in a different way, having implemented it myself than the documentation says, so I can talk about the gotchas, but we will use theirs. So let me share my screen real quick, and we will get rolling. Okay, so we have the A2A website, and let me just go ahead and share the link to this for everybody if you want to follow along on your own. So I just commented that one out. If we look, I swear I saw that. There we go. Okay. I was about to be really mad if I couldn't find the diagrams again.
There you are.
We'll do one more time just so we can see that a little bit better.
It's kind of not zooming the picture.
No, it's not. Let's try to go. Let's just go straight to the picture. Woo!
There you go. Woo, that's better.
Okay, and this is actually, I think, all you really need to see. As far as like where does MCP fit into the picture and where does A2A fit into the picture. So you have your AI agent, right? This is your, I like to say, autonomous artificial intelligence that lives out in the sky. And it communicates with an LLM, a large language model. That could be Claude. It could be one of OpenAI's LLMs. It could be Llama. It could be Gemini. It could be any, right? Yeah. That's actually the really nice thing about AI in general these days is that you get to pick your model. Each has the things that they're good at.
It's thinking, translating it to things we usually talk about, right? Serverless. It's like you could have an agent with Llama and then an agent with Nova. It's similar to having a Lambda function with Node.js and another one with Python and another one with C#. Think about that.
Yes. Yeah, totally.
You don't have to run them all with the same
reasoning.
Sorry, reasoning.
We're not there yet. That word's too scary for me right now. I'm not ready for that.
But yeah, using a different LLM, that's kind of purpose-built for what the agent is doing. Or not purpose-built, but works better with the agent, what the agent's doing, or reasoning.
Sorry. Right, based on what they're trained on and how they're trained.
Yeah.
Yes. So you have your agent, and it's the code that we're writing as developers. So this agent is given a system prompt. It has an agent framework like LangChain or Bedrock, or there's a handful out there right now. Mastra has your LLM, which is the brain and the reasoning model, and then that would connect to MCP servers, which is really what we focused on, Andres, for the past several episodes. And this is your tools, right? You can see that it has tools, it has resources, it has a bunch of different things that it can access to, so it can perform actions, right? It reasons that based on what you said, I need to go do X, Y, and Z, and it goes and it actually does those through the use of tools. Super nice.
Yeah.
Okay, so what A2A is it is allowing these little other agents to communicate with each other. If we go and we take our office example from a couple of months ago, this would be where Michael Scott tells Angela to plan that party, that pirate theme party, and he goes and tells Pam to go draw a poster for it. And I forget who all the people were. Kelly for the communications, go email this out.
Yeah, to get the location and then get the financial approval. So yeah, different agents that we had.
Yes, and a big thing that we need to really camp on here and talk about is that each one of these agents specializes in something, right? You could, in theory, have a single agent that does everything. You shouldn't. You shouldn't. Just like you wouldn't give a single developer access to everything inside of your enterprise or your your work, right? You shouldn't. You shouldn't. You're not going to do that with your AI agents as well. You're going to scope permissions down to individual things, and you're really going to write those system prompts to make them specialize in a certain thing. And what I think is cool, this is a very forward look from Google, but in their promotional material for A2A is they're talking about you, a developer that works for company A, really just wants to communicate with the Travelocity agent to go ahead and book your stuff for you, right? You don't actually want to build the agent that goes in and creates the MCP server to communicate with their APIs. You just want to communicate with the agent.
And Travelocity might have internal APIs and all that stuff to do the real booking and all that fun stuff, which could be abstracted via the agent. You can communicate, and then that agent can communicate with those MCP tools, right? So it can be a little bit abstracted via the agent, and the agent is just purpose built. For example, like you said, they're specialized in one area that they can just do their thing.
Yes. Yes. And so that's a very forward look, because nobody has these yet. Andres, asking me how I know that.
Because you probably looked around for existing agents.
I actually didn't. But the way that I'm assuming.
Okay, so why do you know that?
That is an assumption. Yes. Okay. Thank you. I'm glad that you asked. I know that because in building an agent with A2A myself with JavaScript, granted, I did put extra pain on myself intentionally. The amount of friction, how hard it is to implement an agent with A2A as it stands of today, right? Today is June 12th, 2025. It will get easier, but as of today, it's not easy. It sucks. It's bad.
Okay.
And there's this website that we're on has a lot of documentation, but not a lot of developer documentation. This is specification. This is not how to actually build. Now you have an SDK reference. This is actually new since I started looking at it, because when I started looking at it, there were no SDKs. And man, we got spoiled to MCP, because MCP came out in all of its popularity, and you could just do npm install model context protocol and you're off to the races. It is not that way with A2A, not for JavaScript. Now, since I started doing research and building, they did come out with one for Python. So yay. And, it makes sense that, it makes sense that they did Python first, because that's what data scientists use. And that's the AI programming language. But you and I, Andres, we speak the English language of programming languages.
Yep.
We speak JavaScript. We don't use Python. So I decided to implement all of this with JavaScript. Now, to Google's credit, they do have an examples section in the code. And I think there's code in here. Let's go here. Yeah, so here's the code that implements like all the documentation for the A2A protocol and the standardization. And there was a samples folder in here, and it had JavaScript, it had Python in there. And
nice. Okay.
I built something. I copied the code. I cloned the repository, changed some stuff, and got to work. And then I came back like 2 weeks later, and the samples directory was gone. It was just totally gone. You don't see it in here anymore. It's completely different. There is a samples repo in here. It moved repositories. Here it is. This is even new since since I looked a week ago. It's moving so fast. In the A2A samples here, this is where my example moved to. But the thing is the entire thing was broken. Like the amount of breaking changes that they're pushing out right now in the very early days of the spec is absolutely ridiculous. Not only was the sample code broken, like breaking changes in the sample code, but also the specification had massive breaking changes as well. For example, if you wanted to send a message from an agent to another agent. You use JSON RPC, standard format for defining what you want it to do. The methods were different. Before it was like tasks/send to execute a request on an agent. Now it's messages/send or messages/stream. And everything was different, like even the schemas internally.
So do you think, yeah, I mean, because you mentioned this, a couple of days ago, right? It's like, hey, I'm rerunning this and it's completely broken because they did some pushes, right? Obviously, it's in beta, alpha, whatever, right? It's version 0. Do you think, like, when we started working with MCP, that we got on it a little bit later, it was a little bit more stable than what we are doing right now with A2A? Because when was MCP has been close to a year now, right?
No, it was announced in November of 2024, and it really didn't get we're talking about MCP just to make sure everybody followed that. MCP didn't really gain its big hype until March of this year. And that because that was when everybody started saying, yeah, we'll use that. Because obviously Anthropic was using it. They developed it, but OpenAI said they were going to use it. And then AWS came out and said they were going to use it. And so everybody was like, okay, well, this is the next big thing. I don't think we're there yet with A2A. I don't think everybody has said, yeah, we're going to use it. And in fact, I'm seeing quite the opposite right now. Like we see, what was it, 2 weeks ago, where we saw AWS release Strands agents, which is a direct competitor to this. It's only a Python thing. There's a couple others as well that really are ultimately trying to compete against this. Now, what everybody else is doing is they're making it easier to build agents in their ecosystem. What A2A does is try to have that agnostic one. So there is actually some benefit to using it. I like it now that I understand it, and I'm kind of caught up with the current spec. I did not like trying to learn on a moving target. Did not like that.
Nobody likes that. It's having to relearn, right? You spend a week learning something that's kind of what's happening right now with everything, right? It's you learn something that's irrelevant by next week. So it's a little bit worse here that what you learn and implemented now is completely not working.
Yes, but it works again. I have scrambled, I've gotten it working, and I actually really like it. What I like about it is it's very opinionated. I am a big fan of opinionated design because a lot of times I don't care to have an opinion. And if you feel strongly about it and you give it to me, I'll probably use it. Probably use it if it makes sense.
Make it easier for me, right? That's where I find opinionated frameworks and stuff. It's make it simple for me to not make mistakes or prevent me from making a bigger dent or bigger issue of something because I just don't know about it.
Yep. Do you want to look at some code?
Always. I mean, that's what I live for.
Do you feel like we have covered enough of the foundation of what A2A is?
I do
so far.
Think so. Yeah, I think we'll get a better line of depth once we look at the actual code, right? Because as with everything in our line of work, theory, it's simple. I mean, it's just two agents communicating, right? How complicated could it be? So now, if we dig into it and maybe see a few tears come out from your eyes because of what the struggles you had, we'll understand a little bit better. I wonder if LinkedIn user is. So AWS Trans Agents will support A2A protocol soon, but it sounds like still it is a primitive stage. So yeah,
it is. It is. I mean, it's functional as long as it stops making these significant breaking changes. So let's look at code and let's actually learn. Let's learn stuff. So everything that we've been doing over the past several months has been built in this remote MCP agent repository. At this point, I really need to rename it.
Yeah, because it's not remote MCP anymore.
Because it's not just for that. That's at this point we almost overlook the remote MCP agent piece of it. But I want to go over these major pieces and what I had to do to get it working. So these are the files up here. I have this A2A folder in this repository. And actually, Andres, while I'm going through this, do you mind? Will you go to my GitHub, go to that remote MCP agent repo and just paste a link to that in the comments for everybody, just so they can take a look at it?
So since I'm a guest and I'm not logged in, well, if I get kicked out, I'll be right back.
Okay. I'll just keep talking. I probably won't even know that you're gone.
Oh.
That was rude. That was rude. That was me. I would know. Okay. So that. I stole these files from Google, from that repo. Specifically the samples repo. And then I also changed a lot of things because that's kind of what I do. Because I had to really figure out like what are the pieces that make A2A click, and how are they different from anything else that we've seen out there so far. So I did actually manually copy these one by one instead of cloning the repository and make changes there, because I wanted to see how does this thing actually work. And just like MCP, A2A has the concept of a client and server, which, just to say it in other simple terms, that's the caller and the callee. That's a terrible. That's not a simpler term.
I've been using that term recently for something I'm doing, but it's the callee service, or in this case, a callee agent and the caller's agent. So it's fine.
Yeah. I actually saw a really good diagram. Let's see if we can find it again. It might actually be in the video that they have here in the introduction, but it has, it's fine. It has a person, and then it has a client application, like the actual app that you're using or the website that you're on. And oh, there he goes. And then the calling application calls a client, an A2A client, which is exactly like what we saw with MCP, remember? And then the A2A client would end up calling an A2A server, which really you could think of as an individual agent. It's almost like saying the endpoints that it's calling are agents themselves. So we have client code in here, and we're not actually going to go through that today because there is so much to cover. There's so much detail. We're actually just going to camp with server, because that's where a lot of the complexity is. And we're going to focus today on single isolation. Oh, here he is. Welcome back.
It did kick me out, as expected.
I don't really know what you're doing.
I was logging in so I could add the comment to be able to share the GitHub repository.
Oh, I see. Thank you for doing that. Anyway, so I was just covering, Andres, while you were gone, that we're not really going to focus on the client side of A2A. We're going to focus on the server side, because there is so much to cover, and we want to focus on what is the server actually doing. Cool. On a later episode, maybe the next one, we'll work on the client, and that's where we get into really that multi-agent collaboration piece. But today we're going to focus on what is a single agent doing when you call it or when you invoke it. So we're going to pretend to be a client, okay, and we're going to call the agents that are defined by the A2A standard. So we have a, gosh, there's just so much in here. There's two endpoints that define an A2A server. One is an agent card, and this is the discoverable piece of your agent. Your agent card, let's jump over to mine. is the definition of your agent. This is what an LLM or the calling agent, a client, would basically pull in to see, hey, what can I ask you? What is it that you say you do here? So it has things like the description. What is the actual invocation URL of this agent? Who made it? This is important. The capabilities. So this actually will.
How it can send the data back? Is that basically the?
It's telling the agent how it can request the data.
Okay.
So if it wants to stream, it would look for an agent that has a streaming capability set to true. It also has, push notifications and transition tracking. So it also has skills, and down here, of course, remember, we're using our garden example. We're building stuff for my farm while we're learning. And so this is basically the garden agent. And so these are the types of things that you define in your agent card, so another agent can look at it and say, that's what this guy does. This guy manages garden beds. He can manage a whole seed catalog. He can add plants or remove plants inside of my garden beds. And then I can also pass requests for how much I'm harvesting out of that garden too as well.
It's like the agent's resume.
Yeah. And this is not unlike what we did when we defined agents in AWS inside of Bedrock. It's just a different format, but very much the same thing. And you define everything in here with natural language examples. And because that's what LLMs read. They read natural language. So very nice. Very easy. So that's one piece. Okay. That's one of the endpoints that get defined when you're actually defining an agent. That's what I would say is the fun part.
Maybe the simple part.
I don't know. It's the documentation part. So I guess a lot of developers will think that's the crappy part. I don't know. So we have that, and then the other thing is, let's go back to the server here. The other thing, so that's the well-known agent JSON. So that's one endpoint. The other endpoint is a post to the root. And that's the one where it's going to accept that JSON RPC message that then tells it what to do. So instead of having a bunch of different endpoints for your agent to do a bunch of different things, it has one endpoint, and it defines inside of the body that it posts, inside of the body, what it wants you to do. All right, I'm just going to type it from memory.
I sent it in our super exclusive private chat, so you can just paste it. Since I'm a guest, it doesn't let me share links.
All right. Once we're past this, I'm going to start asking you questions again.
There we are.
Here we go. Feel free, everybody, to take a look at that. Okay. So did you hear the two endpoints that an agent defines with A2A?
No, I did not hear that because I was
okay, because that was a test and
I failed.
Yeah. It has the agent card, which is the definition of what the agent does. And I know you were at least semi paying attention when we talked about that.
Yeah, that's the resume. That's the resume.
Exactly. Yes. And then you also have the post, which is the one where you're asking it to do something with a JSON RPC payload. Okay. And so that one we'll look at in Postman when we're actually hitting the agent that I have up in the sky.
So does this mean, and bring it back to like OIDC, right? So you got even the same well-known path kind of there, right? So it's first discovering what you can do. So the agent is trained to do a get to know what the agent does, to then, okay, you do what I need to do. So I'm going to post with my request. Kind of the two-step.
Yep.
Cool.
And there's a whole lot of nuance that we just glossed over with I'm just going to post. There's so much that we're going to talk
simple,
about.
Alan. I don't know why you struggled so much to set this up.
You do this to me every time that we do this. I struggle and I sit here in my off time and I'm learning and struggling because nothing's documented because we're on the bleeding edge and it changes. And I'm pulling my hair out. And then I guess good for me for figuring it out and making it look simple, because that's what you always say. Is that all it is?
Like a manager. It's just that.
It's just, yeah, can't you just make it do that? And so that's really it for the servers, the main entry points. Let's just say that. That's it for the entry points. Now there's a whole lot of nuance once you get in the doors here. We have the
Okay.
definition and we have the do work endpoint. Now this, I again, I kind of want to make this distinction here. It's not that even if your agent has, let's just say 40 capabilities, which is too many for an agent. You only have the one endpoint, and it's from the body that you pass into that one endpoint where you are telling it what you want it to do.
Okay.
It's where you tell it what you want it to do, and it's where you tell it how you want it to act. Now let's move on to that. How do you want it to act? And there's a couple of different ways you can get an agent to respond back to you. And again, it's really based on those capabilities that we talked about. The two main ways to ask an A2A agent to do something for you is to do a request response or to stream information back. Now, let's talk about the concept of streaming here for a second, because this is actually a really important part to the A2A protocol as a whole. And I'm going to go back to the documentation. I'm not an expert in how things are laid out in here, so I might struggle to find what I'm looking for. Yeah, these are like the big things that we need to camp on and really understand, because these are fundamental concepts with A2A. So whenever,
can you zoom in 2 clicks?
Yeah. Yep.
Thanks.
So a task, we're going to come back. We're going to sidestep to this, and then we're going to come back to streaming. Okay.
Mm-hmm.
A task is the highest piece in the hierarchy. And it has examples in here, right? Go generate a report, go book a flight. This would be generally the request that you'd see coming from an end user, right? For me, for contextual example with our garden agent, maybe I take a picture of all of the seeds, all the seed packets that I have, and I say, go file these in the seed catalog, because I just bought more seeds than I need again.
Mm-hmm.
So that's a task, right? Because that individual task has a lot of things to do. It has to parse that, like OCR it, figure out what is actually in there. That has to go fetch information from a seed database, or maybe the LLM knows, but then it has to go in and iterate and actually add those things to the seed catalog.
Store it into Yep.
That's right. That's a task. It's this high order thing that basically tracks, I asked you to do this. And, this could be one thing. It could be a one shot, or it could be multi-shot where it's doing a whole bunch of different things. A message is a single relay between a client and an agent. So a task would kind of just like be that bigger idea. And then a message would be go in and save this seed to the seed catalog. Let's just say that.
More description. You could say it's your, let's think of it as a Jira. You have your Jira title, and then you have the description with your acceptance criteria. That would be the message.
Yeah, I mean, maybe. I guess you could do it that way. If I was likening it to Jira, I would say a task is closer to an epic, and a message is closer to an individual Jira ticket inside of that epic.
Okay, I see. Cool.
That's a great example. I love that. And then a part is actually a piece of a message. So if I want to say, go in and save these seeds in the catalog, but I gave it a picture with my phone, I could give it a file part that's actually the image, and I could give it a text part, which is the instruction that goes along with that. Okay. Catalog what you see in there. So that actually, let's just say those two things, right? Both parts would come in one message generally when you're doing something like that. And there's other things in here that we're not going to touch on today, because there's just too much to this to cover in the hour that we have. Oh gosh, it's already 40 minutes in. We'll Ooh, okay. I guess we'll move a little bit faster. We'll talk about, I mean, artifacts are exactly what you're saying. If you've been in computer science a while, you know what an artifact is. It's an asset that gets generated and shared around. So let's talk about request response versus streaming. We won't talk about push notifications. You know how I get all huffy when we talk about push notifications. So Andrew Robinson asked, is each piece required? Like in a part? No. You can totally just send a text part. You can totally just send a file part. The code on the server actually can determine what types of message, what the parts are, and act on that. So let's look at some code, because I think this is going to be really important. I have an example garden agent, and this garden agent, I'm going to say what it does, and then we'll look at the code.
Yep.
It receives a natural language command from the client, and then it goes and asks Claude that's hooked up to an MCP server to satisfy said command, basically to answer it. So in here, because we're tracking tasks and we're tracking long-running events, what we're going to be doing is we're going to be emitting tasks out the whole time to show that we're working. So whenever this agent runs, it'll say, if this is the initial task, hey, I'm working. I am doing something now. You've submitted the task. Here's the defined task state. We're good, right? I acknowledge that I'm starting it now. And it's going to say, I'm processing. So it's going to send an update task and say, hey, I'm doing work now. Then from here, this is the actual work. Like, this is the code that is running and communicating with Claude, where it's taking the message history, the history from the task, so it can keep an actual dialogue. And it's saying, all right, let's pass this to 3.5. Here's my remote MCP server. That's the MCP server support is actually in beta right now, and it came out while I was building this demo. Yay!
Oh, nice.
Yes. So I had to add this little beta tag in here to get this guy in, and to get Claude to communicate with my tools. And then it just asks, right? Here's the response. Let me filter it out. Let me format it in the A2A format in the style that it expects. And then publish that update one more time to say I am done. So you can see here, I am done. And I pass back what Claude said.
Okay.
Yes, and then I'm done. And then that's really all that this agent does. Yay! And
is the state, the task state, and all that currently just stored in memory right there?
No. I wish I had more time today. I wish this was an hour and a half. There is the concepts of a request handler in here, which you don't actually see. It's part of this agent executor class that I overwrote, that you determine what is the persistence here. So I, of course, made a memento request handler naturally, right? That's what I do.
Okay.
And what this is doing is it's actually going in and storing the tasks and the pieces inside of a cache item for you automatically. So you have that in a remote area. And then the part that I wanted to talk about next is the streaming pieces. It goes and it submits those over a topic. And the topic is based off of a context ID, which is essentially a reference identifier for what's going on. A set of related things. So that's kind of an under the hood thing that actually is handled for you, which is one of the nice things about this code that Google provides when you're actually building an agent, is it just kind of does those things.
Okay.
It has a whole event bus baked in. That's part of the opinionated design that it has, where it has an event bus. So if you do have other agents that want push notifications, you can just say on event act. and it just subscribes that way, and it's pretty neat.
Oh, that's nice.
Yeah. So that's really the length of the Garden agent, right? It implements this agent executor, which is where all of our A2A server logic exists. And again, we've given out the repository for this implementation of it. And I built this in Cloudflare. Ask me why I built this in Cloudflare.
I kind of know because you told me. Because of the agent capability to respond via stream or a simple response and flipping between that, right?
Yes. So now we're going to talk about streaming. I feel like I've been leading up to this for like 15
Yeah.
minutes.
Yay!
So the streaming response is really nice because nobody likes waiting. That time to first bit being really low is generally very important when you're in low latency systems. And also when you're keeping people on the hook as well, right? You don't want people waiting for an LLM to respond until it's completely done because that takes forever. You like to give status updates. And you tell the agent, and it's one endpoint, I either want you to do a request response for me, or I want you to stream the results. And it does as a server sent events to stream the results generally.
Okay.
And Lambda, this is the Believe in Serverless show, right? We're doing things serverlessly. I could totally put this in a container and not have many of the problems I stricken myself with, but we're doing it serverlessly. So I was trying to get it to work with Lambda, and a single Lambda function can either give you a request response or it can stream. It handles both, but not together, not in a single Lambda function. So Lambda was out for me.
Yep.
Which was unfortunate because I really like Lambda a lot. So I used a Cloudflare worker, just Cloudflare's Lambda, and it can handle request response or streaming conditionally based on the body of a payload. And to do that, I used Hono. I don't actually know how to say it. Hono. It's like Express if you've ever used Express in JavaScript. Yeah. It's just lighter weight. There's really no dependencies on it at all, which we have to use because Cloudflare runs in a limited JavaScript environment. It's not Node.
Yep.
So we use Hono. I'm going to say both every time I say it, to conditionally either return a request response or a stream. And if you ask for a request response, you're only going to get that completed task. So you see here, we sent 3 in this, right? We sent,
which is similar to it's similar to calling a Lambda function asynchronously, right? You're going to get a 200 back. Even if it fails while it's processing.
I would say no to that. Okay. It's not like that. And the reason you're still on the hook. You're still on the line either way. In an asynchronous Lambda invocation, you have to go and fetch data afterward. It's not going to publish a message to you when it's done. That's not what this is doing.
Okay.
This is actually keeping you on the line via server sent events and emitting updates on the go. So what's going to happen is it's going to look for, let me jump into this method. It's going to look for final. When you pass final true as one of your tasks, that's when a request response is actually going to return a response. Otherwise, it's just going to throw all these other pieces away. Let's look at it. In our last 10 minutes, let's look at it because I have some cool stuff that I want to show. Is this it? No, that's not it. Let's use Postman. Okay. So this is the URL to the agent using A2A. Now, Postman in this context, like what we're doing right now, Postman is being the client, the A2A client. We're actually sending a message, a request. In this case, it's an actual message, and we want a response. So let's look at send first. So this is going to be a request response. We'll say the context ID is Alan, and we're asking it, how many garden beds do I have? Remember, this is connected to our MCP server that's managing the garden, and this is going to be talking to Claude. So I hit send and it's waiting. This is why we stream, because I don't like seeing this. Is it working? No, it's like 7 seconds and it comes back and it gives me all of these different things. Yeah, I'm going to help you. And then, so this is everything that came back from Claude, right? It did a multi shot. So it said, yes, I'm going to help you. And then it did its tools. And then it says, here are your beds. You have 4 garden beds, the left triangle bed, the center bed, the melon bed, and the butterfly garden. Cool. That is actually true. It did actually go in and communicate with our MCP server. So clap for that, because that was that. I was so happy when this worked the first time.
Yay.
Thank you. Thank you. Thank you. So I don't like it when things take 7 seconds.
Yeah,
that's way too long for me. I thought it wasn't working the first time. I was like, oh, dang it. Something's hanging. Something left a thread.
Yeah.
Yes. So instead, what you can do is you can do stream. This is the method of communication you're telling the agent you want to respond with. And Postman actually handles server sent events natively, which is really nice. You'll see how the body changes. So if we hit send, you can see it's coming in with these individual tasks that we saw. This first one, hold on. So it still took about 7 seconds, but we saw that it was actually doing stuff. Like this first one said it was submitted.
The good old progress bar.
Yep. And there's the history. How many garden beds do I have? It's just giving me, everything that's going on. Now it's working. And then this last one was the completed, where it told me, here are the 4 beds that you have.
Okay.
Cool.
That's nice. So here's a question, right? Yeah. So because this is the caller agent in that scenario, would the caller agent know to stream it versus send do a request response?
Yeah, we're gonna cover this next time. Okay, we're gonna do this next time. But I want to show you real quick first. Let me change this super fast. We're gonna do get, and we're gonna do well-known / was it agent? I think it was agent / JSON. And so down here, you can see that it comes back with what you can do. So that client, in answer to your question, it would pull this back first to discover, what are the capabilities and what can I do here? It can see that streaming is true. And then really based on how it's coded and what it's instructed to do, that caller, it might stream it, it might not. If it's just emitting status updates back, totally do that. But doesn't have to. Again, it's kind of based on the implementation. It depends, in other words.
I love that.
So here's another thing that I think is really cool. So I spent some time getting the A2A server code to work with Momento, because as a human, I like seeing progress. I like seeing status updates, right? It's very important.
I still think you're a robot, but we'll leave that for another conversation.
Different day. Yes, that's a conversation for a different day. So I built this little demo in here inside of Postman that's subscribing to a topic. Let's see. Where we can set inside of the parameters. Basically the context of what's happening. So if we go in and we set the context to Allen 2, sent. This is long polling, and we had a whole thing. That's unfortunate.
Oh.
We'll just. Oh, gosh. Hopefully, I have access to a Momento API key here quickly. Yeah. So I really want to show this because I think it's cool.
Yeah, I want to see it. So while you do that, I'll keep talking. So what this is doing, you're hooking up to that Momento the topic and the cache that where you show that it's storing all the tasks, the history of the tasks, right? Where
Yeah, it's not actually. Yeah, it's not storing the individual tasks, the things that are being emitted. What we're going to be showing is it going and emitting those little individual tasks, those status updates. There we go. Okay, so this is long polling now. So it's gonna.
I was ready to shame you on the API key, but Postman hit it for you. So props to
Yes,
Postman.
I saw that. Let's make this work. So
Can you get rid of the chat thing? It's getting in the way.
What chat thing?
Yeah. There you go.
So again, this is long polling. This is waiting for a message to be sent. I guess Postman has a 30-second timeout. This is waiting for Alan 2. So this is the context we're going to be sending in. Let's go back to Postman. We're going to say context ID Alan 2 stream sent. And so what this did was it actually published to that topic. And what I did here is I made a visualization. Just even cooler. Nice. Yes. So it should actually come in once Claude is done with a third message. This is the visualizer that just builds an HTML page behind the scenes. So it's just long polling, right? Something comes in.
So is this little visualizer actually hooking up to Memento with a key, and it's just waiting here inside of Postman? This is
inside of Postman. Yeah, it's pretty neat. So in here, okay. Something failed along the way. Yeah, that's why we didn't get another one. Failed to connect to something. It couldn't connect to garden tools, which is always seen. We've seen this a couple of different times.
Yeah, when we were doing the MCP server, remember we had to turn it off and back on, which is weird.
Yeah, so let's try it with a different one because I want to show it work all the way. So I changed the context ID
to 3.
Send, and so it comes in, and these.
So it's the submitted that you got the second one.
Agent. Okay, I don't know what's going on with our MCP server, but
we saw. Actually, I mean, we at least got the failure. We could see the step.
Yes. Yes.
That's pretty nice. Nice introducing that little bonus on with the visualizer in Memento. I didn't know you could do such a fancy visualizer.
Yeah. Right. Yeah, it's pretty neat how it works like that. So the reason that I wanted to show this, right, I'm not just saying this is cool because I work for Memento. This is really important because as long as you're passing that context ID around, like when we get into a multi-agent collaboration mode, if you will, sending these messages back is going to be really important to get an overall show me everything that happened. So it'll show you all the different agents that is jumping between, and it will just compile everything here. So if you do have somebody waiting, you can absolutely have a running log of what's actually happening to keep that person entertained, if you will.
Yeah.
So it's really important to do that. What this is doing is it's extending the existing capabilities of A2A. The emitting and the streaming really is designed to be the client and the server, but I thought it would be a good idea to show this centralized and remote as part of it.
Yeah.
So you can get that rolled up into one. Okay.
That is pretty much.
We're at time.
Yeah, exactly the hour. Really nice to see it working, right? And all the steps.
Yeah. Yep.
If anybody has any questions, feel free to hit us up either in the Believe in Serverless Discord, directly and publicly, and LinkedIn, Twitter, X, whatever. Happy to keep this rolling, right? We'll probably have this will be broken probably by next week when a new version is released. But Alan makes it all seem so simple. So thank you.
Yes. We're going to be doing a pretty cool example next time that's going to be talking about the actual multi-agent collaboration workflow. I've been working on a farm animal addition to all of the garden stuff, and the farm animal piece is like 25 endpoints. It's a lot, and
Yeah.
it's a lot more tools when you break it down from endpoints into tools. It's a lot more tools than I would like to have in a single MCP server, because that context, you pay every single interaction for that LLM to read that list of tools in the description. So that goes into the context that you're paying tokens for. So you don't need that. I broke this 26 endpoint-ish API up into 5 different MCP servers. So what we're going to look at is we're going to look at multi-agent collaboration with A2A, where we have an agent for each one of those servers, and that basically orchestrator that knows how to come in and see who do I need to talk to get this. That way we're going to scope our context down. We're going to scope our permissions down. We're going to have the agents that really specialize in one thing, and we're going to do it all in A2A.
That sounds very exciting. So
yes. And then ultimately what we're going to do is, ultimately what we're going to do is we're going to hook that up to an Alexa skill in a future episode. So I can just walk into my house and say, hey, Alexa, I just harvested 8 chicken eggs. And then that can update on my phone on the web page that tracks my farm.
And then you'll start selling this and become a billionaire, Alan.
Yeah, then we won't do the show anymore.
Yeah. You'll just buy me a house and we'll be good to go.
Oh, I guess you were a part of it, weren't you? Yep. Okay.
Cool.
Well, thank you everybody for watching. I had a great time with this. Again, there's so much to A2A, and it's changing so fast, and there's not that much support for JavaScript in a lot of the AI stuff that's coming out right now. So if you follow that or watch that GitHub repository that we linked, if you go to my GitHub, Alan Helton Dev, remote MCP agent. I'm updating that one pretty regularly as I'm learning. So currently it has the API for the farm animals and the 5 MCP servers up on there. We'll talk a little bit more about how that's structured, and we'll talk about the agents that it runs next time.
It's a little monolith.
Yes, just don't expect the README to get updated. I'm just super bad about updating that README. It's just not.
Well, let's see if I can get an agent up and running to do that for us.
That's fine. Yes, I would do. Yes, that can be your part. That can be. Yes. Okay. For real, thank you, everybody. I always enjoy this show. I like learning along with you guys. I hope you guys learn a lot. The A2A, there's been a lot of confusion around what it is. Is it an MCP thing? No, it's not. It's how agents communicate, and it's a very opinionated but structured and well thought out way to do all of that, solving a much bigger problem than MCP was.
Yeah. Oh, yeah.
Okay.
So
Until next time, I think we'll do.
Working, and we'll see you, everybody.
All right. Bye, guys. See you next time. So awkward.
I know. Why is it not ending, Alan?
I don't know. This is the part that I share the clip at the end.
Yeah.
That's the fun. It's like, this is what we do on the stream. We just wait for it to end. Oh, having trouble connecting to stop the stream. Bye, everybody.